All right, so today what we're going to do is we're going to do angle bisectors within a triangle. So if you remember back to 5-1, 5-1 was perpendicular bisectors, and we had perpendicular bisectors meeting at the circumcenter, okay? So today what we're going to be talking about is angle bisectors and where they meet. So remember that an angle bisector is a line segment array that divides an angle into two congruent angles. So if you look here, I have this one angle right here. This ray cuts it in half, creating these two equal angles. Okay, so that is an angle bisector. It creates two equal angles. Okay, so for example, if I had an angle, let's say this whole angle is 50 degrees. Then when I bisect it, this becomes 25 and this becomes 25. Okay, so that's what an angle bisector does. It cuts the angle in half, creating two equal angles. So what your angle bisector theorem is going to say is if you know you have an angle bisector, then any point on that angle bisector to the edges of your angle are congruent. So anywhere on this black line to the yellow angle is going to be congruent. Okay, so from C to A and C to B is equal. If I drew another one from here to here and there to there, those two segments would be equal. I could go way out here to my edges. Those two segments would be equal. Okay, so from anywhere on your angle bisector to the edges of your angle, that distance is congruent. Then the next, or the converse of that, is if I know from a line inside my angle to the edges of my angle is congruent, I can see they are right here, then that line that they came from, or the line in the middle, is going to be a angle bisector. All right, so pretty much from your angle bisector to the edges of your angle are congruent, and then vice versa. So let's do an example. We want to find the length of OP. So I want to find this length. Well, I can see right here that this line LO is an angle bisector. So because I know segment ray LO is an angle bisector, I know that from anywhere on that line LO to the edges of my angle are congruent. So that means MO is equal to OP. So we can set those equal to each other. So MO is 6x, and that's equal to OP, which is 3x plus 12. You solve, subtract a 3x on both sides. You get 3x is equal to 12. Divide by your 3. And you're going to get that x is equal to 4. But again, it doesn't want x. It wants the value or the length of OP. So we got to plug that in. So OP is equal to 3 times 4 plus 12. So OP, 3 times 4 is 12, plus 12 gives me that OP is equal to 24. And that's it. All right, so again, I knew this was an angle bisector from these two congruent things right here. Then I set those equal to each other and solved. So what I want you to do is do the next two on your own, and then unpause when you are done to check your answers. Okay, so for this first one, we can see that this is an angle bisector by these two congruent angles. So that means from anywhere on this line KM to the edges of my angle are congruent. So that means these two distances are congruent. JM is equal to ML. Because JM is 12.8, that means ML is also 12.8. All right, so that's it there. Over here, we can see that from this line, from my angle bisector, US, to the edges of my angle are congruent. Therefore, these two angles down here are congruent to each other as well. So I can say that 5Z plus 23 is equal to 6z plus 14. We can go ahead and solve, so subtract a 5z on both sides. You get 23 is equal to z plus 14. Subtract your 14. You get that z is equal to 9. But again, it doesn't want z, it wants the measure of TSU. So my measure of angle TSU is going to be this angle right here. So that is 5z, so 5 times 9 plus 23. So 5 times 9 is going to give you 45, plus 23 gives you 68 degrees. Okay, so these are the two ways you're going to see it. You're going to see it that you have congruent angles here and here. So you set your side lengths or your segments congruent, or you can see that your segments are equal. Therefore, the angles are finally equal as well. Okay, now the next thing that we're going to learn is where your angle bisectors meet in a triangle. So let's do this right side first. How many angles make up your triangle? We have 1, 2, 3. So we have 3 angles that make up our triangle. Therefore, I can draw 3 angle bisectors. So let's go and draw our 3 angle bisectors the best we can. So just try and bisect your angle and then go the other way. There we go. There are your 3 angle bisectors. So these 2 are congruent, these 2 are congruent, and these 2 are congruent. Okay, now where this meets right here is going to be called our incenter. So the incenter is your point of concurrency of your angle bisectors, or where your angle bisectors meet. Okay, so if you look over here, here's another one. I have 1, 2, 3 angle bisectors, and they meet here at P. And again, that P is your incenter. So we had circumcenter last time. Now we have incenter. So what the incenter theorem says is that from that incenter to your sides of your triangle are equal. So PX, PZ, and PY are all equal to each other. Okay? So that means that from your incenter to your sides are congruent. Don't get that mixed up with your circumcenter. All right, moving on. Let's do an example. So we have that JV and KV are angle bisectors. So let's stop there. JV and KV are angle bisectors, which means these 2 angles are congruent and these 2 angles are congruent. And V then is my incenter. So I know that from the incenter to the sides are all congruent. Okay, we want to find each measure. I want to find the distance of V to KL. So I want to find this distance from V to KL. Well, we know that V is our incenter, and that from our incenter to the side of our triangle is equal all the way around. So that means this distance is going to be equal to your incenter to this side and your incenter to this side. Well, the only one we're given is VW. So I know that this is equal to VW. So from the incenter to your side is equal. And right here it says it's 73. So that means my distance is 7.3. Not 73, sorry, 7.3. Okay, so on these, sometimes they won't draw your segment from your incenter to the side, but you can draw it any time. Okay, so from your incenter to your side is equal all the way around your triangle, which means from V to JL would also be 7.3. Okay, now is the tricky part. Now it's asking for angle VKL. So it's asking for that angle right in there. So we kind of got to work around our triangle. Well, I know that this little angle in here is 19 degrees. This is 19 degrees. So that means that this angle right here is also 19 degrees because they're equal. So I have the entire angle J. I have my entire angle L. What I'm going to do is I'm going to find my entire angle K, and then you'll see what I do. Okay, Now, the reason I'm going to find the whole angle K is because in a triangle, you have 180, and that's the easiest thing to do. So I know that this entire angle, if I add the 19 and the 19, is going to give me 38 degrees. I can see right here that L is 106 degrees. So all I have to do is subtract those from 180 to find my entire angle K. So what I'm going to do is I'm going to say that 38, actually, let's work the other way. Let's find the entire angle K. That's 180 minus 38 minus 106. And when we do that, 180 minus 38 minus 106 gives me 36 degrees. So that means this entire angle K is equal to 36 degrees. But again, it's not asking for K, it's asking for VKL, which is this little one in here. Well, all I need to do to find the measure of angle VKL is cut it in half. Because I know this entire angle is 36, this is an angle bisector, which will give me half for in here. So 1/2 of 36 is going to be 18 degrees. So my measure of angle VKL is 18 degrees. So again, if they do not give you 1/2 of it, you're going to have to find the whole and cut it in half because, again, angle bisectors cut your angles in half. We'll get a little more work on that in just a second. But before we move on, just know, remember when we had circumcenters, that the point inside that circle was your circumcenter? Well, here we have inscribed. So the circumscribed circle, remember, went outside your triangle. An inscribed circle is going to be on the inside of your triangle. Okay, so that's going to be your difference. Circumscribed goes around. Inscribed is inside. Okay, so inside your triangle is your inscribed circle. All right, so let's label some things here. We want to name the 3 angle bisectors of my diagram. So all I'm going to do is I'm going to look for all of these little symbols. So let's start here. This is 1. CG is 1 angle bisector. Then we have AG, that's another angle bisector. And finally, we have EG. That's my final angle bisector. Okay, so those are my 3 angle bisectors, and the reason I know that is they come from the angles and they bisect those angles. Now we want to name the point of concurrency. Well, where all those meet or all that they have in common is G. So my point of concurrency is point G. The point of concurrency here is called the incenter because, again, it is created by angle bisectors. And from the incenter out to the side is congruent. So all my congruent segments are going to be from G out to the sides of my angle. Or excuse me, the sides of my triangle. So I have GF is congruent to GB. And that's congruent to GD. Okay, so essentially in that example, we just did all of a review of what we just learned. Angle bisectors, incenter, and then what's congruent. Okay, so knowing all that information, let's look at this. We are told that GB is 8x minus 7, and GD is 5x plus 8. Well, we just found that those two things are congruent to each other because they come from the incenter and go to the sides. Okay, so again, I know that GF is equal to GB, which is equal to GD. Okay, so what I want to do is I want to find GF. Well, I know right here that GF is equal to the other two. So if I can find the value of X and plug it back in, then I can know all 3 segments. Therefore, I know GF. So let's first find X. So I know that GB is equal to GD. So let's plug that in. So GB is 8x minus 7. That's equal to GD, which is 5x plus 8. So we can go ahead and solve. Subtract your 5x on both sides. 3x minus 7 equals 8. Add your 7. You get 3x equals 15. Divide by 3. X equals 5. Okay, so I have that x equals 5. What I need to do, though, is plug it back into one of them. I know that all of these are congruent to each other, so it doesn't matter which one I plug it into. Whatever one you plug it into is going to be the segment value for all three of those. It's going to be the same for GF, GB, and GD. So I'm just going to go ahead and plug it into GD right down here. So that is 5 times my value of x, which is 5, plus 8. So GD is 15 plus 8. And when you add those, you get 23. So I know that this segment's 23. But again, that segment is congruent to the other the other two, GF and GB. So therefore, GF is also 23. All right, if you guys are getting confused, please write down questions and I'll be happy to answer them when we are done with this video. All right, so go ahead and do the last two on your own. Reference this example 2 in order to understand what you're doing. And then if you have questions, let me know. All right, so the first one's asking for the distance from X to PQ. This distance from X to PQ. Well, I can see that these two are angle bisectors, okay? So because I know that these are angle bisectors, I know that X is my incenter. And that means from the incenter out to the sides is all congruent. So X to here is equal to X to Y and X to there. Well, I can see that this is equal to XY. XY is 19.2, so that means this distance is also 19.2. Okay, now we want to find the measure of PQX. So I want to find this angle in here. So this is very similar to example 2. We have that this little angle in here is 12, which means this angle in here is 12, because again, we are told right here, RX is an angle bisector. So that means the entire angle R is equal to 24 degrees. And I can see right here that the entire angle P is 52 degrees. So if I find the entire angle X, I can just cut it in half to find this little one right here. So let's go ahead and solve. So for my measure of angle Q, I take 180 minus the other two angles, which is 24 and 52. And when I solve that, I get 104. So then to find the measure of angle PQX, this whole measure is 104, okay? But I don't want the entire angle. I want this angle in here, okay, which is cut in half by XQ. So all I need to do is take 1/2 of 104, which is going to give me 52 degrees. So my measure of angle PQX is 52 degrees. Okay, so that is angle bisectors and incenter. So again, angle bisectors create incenters, and from that incenter to the sides of your triangle are congruent. And then the other thing we learned is that from your angle bisector to the sides of your angle are congruent, and vice versa. So if you have no questions, go ahead and get started on the worksheet. If you do, please ask, guys. We are starting to add more things to this chapter. So if you have questions, let me know.